Hello, everyone, and welcome to Virtual Planetarium Exploring Space, part of our MOS at Home programming. My name is Janine, my pronouns are she and her, and I'll be your moderator today. That means that I'll be reading some of your questions and responses, which you can submit below using the Q&A button at the bottom of your screen here in the Zoom meeting. And if you'd like to see captions during today's program, you can click on the closed captions button at the bottom of your screen and select show subtitles. If you're watching on YouTube or Facebook, hi, thank you so much for joining us. We're so excited to have you here today. Unfortunately, I can't see any of your comments on those platforms. Let's meet our guides who are going to take us on this journey through space today.
Hello, everybody. My name is Talia. I use she, her pronouns, and I'm going to be your guide as we explore a little space today, but I cannot do this alone.
Hi, everyone. My name is Katie. My pronouns are she and her, and I will be your pilot today, flying you through the solar system.
And today we are going to be taking a look at a few surface areas in the solar system. We're going to be talking about some interesting surface features that we find on solar system objects. And we're going to start very close to home. So Katie, let's go into space. So we are using a program here called Worldwide Telescope, which is totally free to download. You can download this program yourself and use it. And you can see we are looking at the Earth and the Moon. Katie has bumped up their sizes, so this is not the actual size that they are. But this will make it easier to see details on both of them right now. We are in fact looking at the far side of the moon, the side that we don't usually see from Earth, if you're wondering why it looks a little stranger than normal. But we have this good view of the Earth and of the moon. And you can see on the Earth, there's a lot of things you can see on the Earth in abundance on the surface of the Earth that you can't see on the surface of the moon. You can see all that green, which represents plant life, especially all that blue, the ocean. You've got that pure white of the Antarctic ice cap visible right now. And you don't really see any of those things on the surface of the moon. But maybe there are things that you can see in abundance on the surface of the moon that you do not see on Earth. So what are some things as you're looking at this, that as you're looking at the moon, you see a lot of on the moon that you don't really seeing on the Earth? Go ahead and put your answers in the Q&A. You may also always feel free to put a question mark if you're not sure, because an important part about science is being able to admit what you don't know.
Oh, we have a couple answers. Craters and less gravity.
You definitely, so that is true. The moon does have less gravity on the Earth because it is smaller. So one thing you're seeing less of as you look at the moon is just less matter, less stuff. The moon is not as big as the Earth. But one thing you do see a lot of on the moon that you do not see on the Earth is craters. Lots and lots and lots of craters. The moon has a lot of craters. Now, you can't really see those craters on the Earth. Is that because there are no craters on the Earth? What do you think? You know, I'm not in danger of stepping into a crater in my daily life. I think we've got a shy audience today.
I think so. Oh, Gail says Earth has craters.
Earth does have craters, yes. Certainly not in the abundance that the moon has them, though. Earth does have craters. A really great example of a crater right here in the United States. There's one, a relatively fresh one, only 50,000 years old, in the desert of Arizona. Barringer crater. There's craters that we can see in Canada, in Africa. We see craters all over the Earth. We just don't see as many of them. And a lot of the ones we see on the Earth aren't these beautiful, crisp, perfect craters that we see on the moon. And that is not because the Earth does not get hit the same amount as the moon. In fact, they're very close to each other in space. So over time, on average, they get hit about the same amount. But Earth has things that the moon doesn't. Some of those things we were talking about before. It has oceans covering most of its surface. An impact on the ocean isn't going to really leave a crater. It has an atmosphere, which causes things to, most things that hit the Earth to actually burn up before they reach the ground, or to even explode in midair, like what happened over Russia in 2013. And that doesn't leave much of a crater. So you're going to see a lot fewer craters than you see just being formed on the Earth than you see on the moon. And there's also the fact that Earth's craters get slowly erased over time. Again, we have a lot of water. We have weather. Weather plays a big part in eroding away craters. We have active volcanoes, which can cover up craters. We have earthquakes. We have a very active planet with a constantly changing surface. And that actually causes old craters to be erased. And the moon doesn't really have that. Craters on the moon can erode away a little bit over time, but mostly they stay there, which means we can actually use craters to figure out how old a surface is. So we can tell that the surface of the moon is much older than the surface of the Earth because Earth is constantly renewing its surface with volcanoes, with weather, with oceans, whereas that's not really happening on the moon. So a lot of those craters that you can see on the moon are actually very, very old. And one of the largest impact areas in the solar system is on the moon. But if we're going to talk about a big impact area, Katie, I don't want to talk about the moon. I want to go somewhere else. I want to go to Mars. So Katie's going to swing us around. We're going to go hit up a new planet. The red planet Mars, which is visible in the night sky these days. If you look to the eastern sky after sunset, you can spot Mars in the east. And Katie's brought us in pretty much right above the target I want to talk about, a nice big impact. You guys see it? It's nice, beautiful. That beautiful round crater, not what I'm talking about. So we've got squarely in the middle here, we do have a large crater. That is Huygens crater, and that is not what I'm talking about. I'm talking about that giant bright area below it. That whole thing is an impact basin. It's called Hellas Basin, and it is one of the largest impact sites in the entire solar system. So it's a little hard to judge what the actual largest impact site in the solar system is because a lot of them are old and have had their edges sort of eroded away. But Hellas Basin is it's in the top 5. And this is the remnant of a very early impact, pretty early in Mars's history. And it's so big that it takes up a giant chunk of Mars's southern hemisphere, as you can see. And you can also see that Mars has a lot of craters in parts of its surface. So we know that Mars is not as good at erasing craters as the Earth is. It has an atmosphere, so it's got something that the moon doesn't, but it doesn't have quite the weather. It doesn't have the weather patterns. It hasn't had water on its surface in a very long time. So it's hard for Mars to erase craters. And you're going to see a lot more craters on the surface of Mars than you do on the surface of Earth, but you will not see as many as you see on the surface of the moon. But certainly something very, very big like Hellas Basin really cannot be easily erased. It's just too big an impact. Now, if we're going to talk about surface features and we're at Mars, there are certain things that we really have to talk about while we're here. So as Katie fast forwards time, because she can do that, to make a different part of Mars visible, I want to, before we swing entirely out, I want to focus on that thing that we could see at the bottom of what looked like the bottom of Mars there, that little white patch. Anybody want to guess what that is? Go ahead and you can again put answers in the Q&A, or you can always put a question mark if you're not sure. We highly encourage admitting when you don't know something. It's a good thing.
Ooh, we've got a couple answers coming in. So we've got ice cap, ice, a cloud is an answer, a crater.
Yes, so as Katie's rotating Mars, you might have noticed it seems to be rotating around that white spot, and that's because that is a pole. That is Mars's south pole. So that is an ice cap that we're looking at. So that is a surface feature that Earth and Mars have in common. They both have ice caps at their poles. Now, Mars's southern ice cap is pretty teeny. It's pretty small, especially if you compare it to the ice caps on the Earth, or even compared to Mars's north polar cap, which is in darkness right now, so we can't see it. It's southern hemisphere summer at Mars right now. But if you've been reading headlines recently about, there were headlines last week that they had discovered some new, they think, underground bodies of water on Mars. It's actually near the South Polar ice cap. And there's a thought that it's possible the weight of the ice is actually helping that stuff stay liquid, because liquid under pressure does not want to freeze as much. But that's a story for a different day. We're talking about surface features, and Mars has some incredibly large ones. Mars itself is smaller than the Earth. It's a little more than half the size of the Earth. It's not a very terribly big planet, but that doesn't mean it has tiny surface features. And Katie has found a pretty impressive one, that thing that looks like a scar on the surface, a big slice out of it. Now, this is a canyon. And of course, we know that that is a surface feature that we find on the Earth. We definitely have canyons on the Earth. And if I was going to guess what canyon jumped into your mind when I mentioned canyons on the Earth, my guess would be the Grand Canyon. It's probably our most famous canyon on the surface of the Earth, certainly the most famous in the United States. And it is quite a big canyon. It's something like 250 miles from one end to the other, and it can get up to a mile deep. And what's kind of interesting is it was very slowly eroded out of the ground in the desert by the Colorado River for many, many years. It was very slowly carved. None of those statements are true for this canyon that we're looking at, which is called Mariner Valley. I said the Grand Canyon's about 250 miles from end to end. Mariner Valley is about 2,500 miles from end to end. So it's more like 10 Grand Canyons long. And if you put it on the Earth, it would stretch from Boston to roughly San Diego. So it's about as wide as the United States. And I said the Grand Canyon can get up to a mile deep. But of course, we've already established that Mariner Valley is much bigger and it is much deeper. It can get up to 7 miles deep in places. And it did not slowly form over eons. We suspect that Mariner Valley was formed in one no good, very bad day, when incredible pressures under the surface of the crust of Mars just caused it to split open, right, which would have been a very, very, very impressive sight to see in a single momentous event. Now, if you're thinking about things on Earth, what sorts of things, maybe you know this and maybe you don't, what sorts of things cause pressure to build up under the crust? Go ahead and if you have an answer, go ahead and put it in the Q&A. Once again, always feel free to put a question mark if you're not sure. So what sorts of processes would cause pressure to build up under the surface?
We've got one question mark that has come in, and then we have gravity, the plates moving, time.
All very good answers. And all things that have very big effects on the Earth. But there's one thing in particular that can build up pressure to immense proportions under the crust, and that is heat from volcanism, from volcanoes. So Mariner Valley is not a volcano, but it's very close to some pretty sizable ones. This area of Mars was once very volcanically active, and Katie's swinging us around. We can see a few of those volcanoes right there. Those three things that look like giant craters, those are actually volcanoes. And this whole area of Mars actually bulges outward a little bit because there was so much pressure under the ground, because there was a big hot spot. This was very volcanically active. And all that pressure, we think, is what caused Mariner Valley to split open and try to relieve that pressure. So not only do we have these 3 volcanoes right in a row, indicating that this area was really, really volcanically active in Mars's past, but on the other side of them is the really, 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 really big one. So if you're going to talk about surface features in the solar system, you cannot not talk about this mountain. It's Olympus Mons, which means Mount Olympus, and it is the tallest mountain anywhere in the solar system. And that means it's much taller than the tallest mountain on Earth, which is Mount Everest, which is a sizable mountain, almost 30,000 feet tall. But you would need 3 Mount Everest stacked on top of each other to equal the height of Mount Olympus on Mars. And its base is so wide, the bottom of the mountain is so wide that if you put it on Earth, it would cover France. So this mountain is enormous. We have nothing on Earth that can measure up to it. And that is partially due to the fact that Mars does not have moving plates the way Earth does, which means the plates can't keep moving over these hot spots. If the hot spot stays in the same spot and is allowed to just build up one gigantic mountain, and also has to do with the gravity. So Mars has less gravity than Earth does. It's smaller. It's easier for mountains to get taller because there's less pulling them down. So there's a lot of factors that go into building such an enormous mountain, an enormous volcano. Now, volcanoes are not, we used to, there was a time when we thought we wouldn't really find volcanoes anywhere but Earth. And then we found these volcanoes on Mars, which no longer erupt. So we knew that there was other places in the solar system that were volcanically active, but Mars is no longer active. So can anybody think of a place in the solar system that isn't Earth that currently has volcanoes erupting? There's a couple of answers that you could give, or you could always provide a question mark.
We've got some coming in. Venus question mark. Venus question mark. Yeah, pretty much everybody who is answering it says Venus. One person does say Jupiter.
Well, both of those answers are at least in part right. So let's go ahead and take a quick jaunt to Venus. Katie, I know I'm running short of time, but I can't not go to Venus. I love talking about Venus. So Venus is a recent addition to the list of places that we think currently have actively erupting volcanoes. We certainly, and this is what we're looking at here is the surface of Venus. Usually if you look at Venus, all you can see is clouds. But we have found lots of evidence from looking at Venus with radar, which is what we're seeing here, that there are definitely old lava flows on Venus. Those dark areas that you can see are very likely lava flows. And those bright areas sort of in the middle, those circular bright areas, they are probably the volcanoes that erupted and provided those lava flows. So we definitely had evidence that Venus used to be volcanically active. And then the evidence started building up that it's not a used to be. We think, it looks like some of these lava flows are quite young. And for them to be quite young, that would have to mean Venus is either still volcanically active or was volcanically active until very, very, very recently. And it seems unlikely that volcanism would have cut off on Venus sometime very recently. So we actually now believe that Venus is volcanically active today, which makes it the only one of the rocky planets other than Earth to currently have volcanoes going off on its surface, and really just makes Venus an even less pleasant place to go hang out, as if, the 800-degree surface temperature, the sulfuric acid rain, those things were already making it a really terrible place to go hang out. And now there's volcanoes erupting as well. So don't build your vacation home on Venus is the moral of that story. But now somebody mentioned Jupiter. And if we're gonna talk about volcanoes in the solar system, there is a place we have to go. It's not Jupiter itself, because Jupiter itself is a gas planet. So it doesn't have surface features the way the rocky worlds do. But Jupiter has moons, and they do have a surface. And one of them is incredibly volcanically active. So Katie, let's go to Io. Very conveniently spelled I-O. So Io is one of Jupiter's larger moons. You can see it through a relatively small telescope, and it looks like moldy cheese. It's also the most volcanically active place in the entire solar system. So again, you can see sort of rounded features. Those are volcanoes. Io is covered in volcanoes. So any rounded features that you see on Io, they're not craters created from impacts. They're volcanoes, because Io has one of the youngest surfaces in the solar system because it constantly has volcanoes going off to create new surface. Now, the reason for Io's volcanoes is a bit different for the reason that Earth has volcanoes, or that Mars had volcanoes in the past, or we think why Venus has volcanoes now. Those planets generate, or in Mars's case, used to generate heat inside themselves. That's why Earth has a liquid core. It's still cooling down from its formation, and that heat inside is creating, it's making Earth's core liquid. It is generating a lot of heat, and that is also generating volcanism on the surface, volcanoes going off on the surface of Earth and of Venus, and in the past on Mars. Io is too small for that to be the case. It is not generating its own heat inside of it. Something else is generating heat inside of Io, and Katie's giving us a great look at the culprit right now, looming behind Io there, the mighty Jupiter. Jupiter's gravity is actually pulling on Io, tugging on it, and making the moon actually flex. And as it flexes, all of its insides are rubbing together the same way your hands rub together and you generate heat doing that. It's from friction. The same basic thing is going on inside Io. Jupiter's gravity causes the moon to flex, and actually friction inside the moon generates a ton of heat. And the only way for it to get rid of that heat is through volcanoes, which makes Io the most volcanically active site in the entire solar system, and means that Io has the youngest surface in the solar system because it's constantly changing and renewing its surface with volcanic eruptions. But that's not going on all of Jupiter's moons. And again, I know I'm running out of time, but I'm going to make one more stop, because Io is the youngest surface in the solar system. You don't have to leave Jupiter to find the oldest. So remember I said we can sort of look at cratering to figure out how old a surface is, how long it's been since that surface was renewed. It's another one of Jupiter's moons that holds the record for the oldest surface in the solar system. So Katie, let's go visit Callisto. Callisto is another large moon of Jupiter, second largest moon of Jupiter, in fact. You can also see this one through a small telescope. And when you look at Jupiter, it will be a bright dot next to it. And it has the oldest surface. This surface has barely changed since the moon first finished forming, and it is just covered in craters. It is a pockmarked surface. It's a mess because there's not a lot going on out here to erase those old craters, and it's been just collecting craters over the last 4+ billion years. Craters on top of craters on top of craters. So if you want to go take a look at a time capsule from the earliest part of the solar system, Callisto's surface is a great place to look. And if you want to study craters, Callisto's surface is a great place to look. If you want to study anything like volcanism, don't go to Callisto. Nothing is going on to change this surface except more impacts. So that's a couple of very diverse worlds just in orbit around Jupiter. And of course, we've got crazy surface features scattered all over the solar system. Janine, are there any questions about these fascinating worlds that I can answer before we totally run out of time?
Yes. So there was a question about Mars, which is, if it has an atmosphere, can you breathe on it?
So Mars does have an atmosphere. It's very, very different from Earth's atmosphere, though. It's almost entirely carbon dioxide, which humans cannot breathe. And it's very, very, very thin. So Mars's atmosphere is about 1% as thick as Earth. So while it does have an atmosphere, it's not much of one. And it's made of a gas that is poisonous to humans. So no, we unfortunately could not breathe there.
Yeah, not a good place. Another Mars question is, if Mars is so cold, why is it the red planet and not all ice and the white planet?
That is a great question as well, because of course we associate red with sort of being warm. It turns out that red color does not come from the temperature. It comes from what's in the dirt. There's a lot of iron in the dirt and it has rusted. So Mars is actually red because it has rusted. And I'm not kidding, it's a rusty planet. And in terms of why it's not just covered with ice, because we know there used to be a lot of liquid water on Mars in the past, that atmosphere is partially to blame. As the atmosphere got thinner and thinner, a lot of that liquid water just evaporated away and was lost to the planet completely. Now, there is a lot of ice on Mars. It's frozen at the ice caps, and there's actually huge amounts of ice underground as well. So there is lots of ice on Mars, but too much water was lost when the atmosphere began to thin to have made it an ice planet. Although there's a moon of Jupiter that is kind of an ice planet. Speaking of the diverse worlds that orbit Jupiter, the moon Europa is a planet completely covered with ice. Not a planet, a moon completely covered with ice. So such worlds do exist. Mars, unfortunately, is not one of them.
All right, I think that's all the questions we have time for today. Katie and Talia, if you want to say goodbye to everybody.
Hi, everyone.
Thank you all so much for joining us today for our exploration through space. We hope you enjoyed it and had some fun. If you'd like to see more shows like this, we do a virtual planetarium show on Fridays as well, where we talk to you about what's happening in the sky that night, somewhere on the Earth, usually from near Boston, because that's where we are, but sometimes we go on other adventures. And as I said, I want to thank you all for joining us. And if you want to know about other virtual programs that are coming up, you can visit the museum's website at www.mos.org/mos@home. You can also follow us on social media. If you're watching on YouTube, you can subscribe to our channel. And anytime we have a new show, it'll pop up in your feed. If you did enjoy today's presentation and you'd like to support more programming like this, all of your support really does help us out. You can visit engaged.mos.org/welcome to support MOS at Home. Today's program was produced using the free software Worldwide Telescope, which Talia mentioned at the beginning of the show. You can find that at www.worldwidetelescope.org. Thank you all so much for joining us today. We hope we'll see you again soon.